So with this lesson, we will start module 1 of the course, and it covers the section 1.4a in the textbook. Section 1.4a in the textbook. So in this lesson, we'll be focused on simplifying, adding, subtracting, and multiplying complex numbers. Simplify, add, subtract, and multiply complex numbers. But before we start, let's introduce the imaginary number, which is the basis of the complex numbers. So that's the basic, and that's where we start complex numbers, with the imaginary number. The imaginary number is that number I that is equal to radical of -1. So as you know, in the set of real numbers, we cannot solve the square root of a negative number. So in order to move on, we need to move on with complex numbers whenever you have the square root of a negative number. So that's why we start with the square root of -1 equals I being the imaginary number. So now if we square both sides of this, will give me I squared equals -1, because you know that when you take the square root of the radical with index 2, when you square the square root of a number, you only cancel the square root, you get the number that was under the radical. So that's why when you square both sides of the first equation, I equals square root of -1, you are left with I squared equals -1. Now, these two relations are going to be very useful as we are performing operations with complex numbers. But another thing that you need to know is that the standard form of all complex numbers is A plus BI, where A is a real number and B is another real number. So I is your imaginary number, such as I equals the square root of -1, but you will never replace it by -1. If you see square root of -1 in your equation, instead of using it, you will replace it by I, but I is going to remain I in your problem. And also, I squared, whenever you have it, you know that it's your job to transform it into -1. I squared is always -1. So that's your bridge from complex to real numbers. And square root of -1 is your bridge from real numbers to complex numbers. -1, square root of -1, you're not going to keep it. You transform it into I. And I squared, you're not going to keep it. You always have to replace it by -1. Now in this case, let's see how we would use it to solve the first example, square root of -5. Square root of -5 will be, the square root of -1 times 5. That is the square root of -1 times square root of 5. And then now if we simplify this, square root of -1, we know it's I. And then square root of 5, it's going to be a decimal number. You don't have to perform the square root. So just leave it as I for square root of -1, and square root of 5 remains square root of 5. So that's square root of -5 equals square root of -5 equals I square root of 5. Let's see, number 2 is the square root of -18. Square root of -18, we do the same thing as we did for square root of -5. So we have square root of -1 times 9. 18 can be written as 9 times 2, because whenever you have a number that is not a perfect square, you need to make sure that you cannot, whether you can or cannot, break it down into one factor that is a perfect square and one factor that is not a perfect square. In this case, 18 is 9, which is a perfect square, times 2. So if you separate all of them, it will be square root of -1 times square root of 9 times square root of 2. Square root of 2 will stay under the radical, and we will stay with square root of -1 is I, square root of 9 is 3, and square root of 2 is square root of 2, because it's not a perfect square. So final answer is 3I square root of 2. So let's see number 3. Number 3 is the square root of -4. We know that -4 is a perfect square, so all we need to do is to break it down as square root of -1 times 4. That equals square root of -1 times square root of 4. And then square root of 4 is 2, so you're not going to say I2. It's always going to be the number and the letter. So 2I. So 2I. Square root of -17. 17 is not a perfect square, and there is no perfect factor in 17. So that's going to be square root of -1 times 17 equals square root of -1 times square root of 17. So the answer is I square root of 17. 24. I think we can have a perfect square in 24. So that is square root of -1 times square root of -1 times 4 times 6. So that is square root of 4 is 2. Square root of -1 is I. And square root of 6 is not a perfect square. So that's 2I square root of 6. Square root of -144. Square root of -144 is square root of -1 times 144 is a perfect square, so that's going to be easy. So that equals 144 square root. What do you multiply to get 144? That's going to be 12, so 12I. So that was these examples. Now let's see number 1. It says write the expression in standard form. So in standard form, it means write it in the form of A plus BI. So basically, if you have to add two complex numbers, so that's A plus BI, in the first one, A is 1 and B is -9. The second one, A is 3 and B is 4. So if you have to simplify and put in standard form as you adding two complex numbers, all you do is combine like terms. You add the constant term, the A's together, and the I and the B's together as a coefficient of I in the final solution. So first So we can do 1 plus 3 is 4, and negative 9i plus 4i is going to be negative 5i. So in standard form, 1 minus 9i plus 3 plus 4i, simplified in standard form to 4 minus 5i. Number 2, now we need to subtract. So same thing, but we're going to do 4 minus 7. 4 minus 7 is positive 3. Actually, negative 3. Negative 3. 4i minus negative 4i. Minus negative is plus. So that's plus 4 plus 4 is 8i. Minus negative is positive plus. So, the expression in standard form of a plus 4i minus 7 minus 4i is negative 3 plus 8i. Now, how do we perform the multiplication? Same thing, you do FOIL. So that's going to be 5 times 8, 40. 5 times negative 3, negative 15i. Negative 7i times negative 7i times 8 is negative 56i, and negative 7i times negative 3i, that is positive 21 I squared. But we don't want to forget that I squared is always to be replaced by negative 1. So I squared is always in your equation need to be replaced by negative 1. So that will give me, instead of 21i squared, that's negative 21. Negative 21. So a number times I squared is the number times negative 1, which changes the sign of the number. So now we can simplify 40 minus 21. 40 minus 21 is 19. 40 minus 21 is 19. So that's 19 minus 15, 15i minus 15i minus 56i. That's negative 71. So that's negative 71i. So in standard form, 5 minus 7i times 8 minus 3i is 19 minus 71i. Number 4, perform the indicated operation and write the result in standard form. Keep in mind, you may have an expression. You may have an expression that has radical, but if you have a negative number under the radical, you need to know that that will be converted into a complex number. So that is going to be square root of negative 16 is I. Square root of 16 is 4, so that's 4i. Square root of negative 16 is 4i, because square root of negative 1 is I, and square root of 16 is 4, so that gives you 4i, minus square root of negative 36. Square root of negative 36 is square root of negative 1 times square root of 36, and square root of negative 1 is I. Square root of 36 is 6, so that's 6i. Now you can simplify. 4i minus 6i is negative 2i. Number 5, same thing. So that's 3 times square root of negative 16i. 16 is 4i. And plus 2 times square root of negative 81 is 9i. So we multiply 3 times 4i is 12i, and 2 times 9i is 18i. So 12i plus 18i is 30i. And that's in standard form because 30i, it's like you have 0 plus 30i. So A equals 0 and B equals 30. Number 6, we multiply, but the easy way to do it is that you can see this, if this is A and this is B, so that's A plus B. And this also is going to be A. This is going to be A, and that's a minus, and that's a B. You may be reminded of this formula that says A plus B times A minus B is equal to A squared minus B squared. So that's a special product that we should have learned in MAT 1033. If you don't remember, that's it. So A plus B times A minus B equals A squared minus B squared. So basically, you have this form right here. You can do less work than FOIL, but if you want to FOIL, feel free to do so. That will give you the same answer. So that's going to be 7 squared minus 9i squared. So that 7 squared is 49 minus 9i squared is 81i squared. But you do know that I squared is negative 1, and 81 times negative 1 is negative 81 times negative 1 is positive 81. So 49 plus 81. So that is going to be 130. So that is 130. And then number 7 to finish. Number 7 is the same as number 6. The only difference is that they give me number 7 in condensed form. I can expand it as 5 plus 6i times 5 plus 6i, and do FOIL. 5 times 5, 25. 5 times 6i plus 30i. 6i times 5 plus 30i. And 6i times 6i is plus 36. 36i squared. And I squared being negative 1. So that is 25 plus 60i minus 36. So that is negative 11 plus 60i. So 25 minus 36 is negative 11. So this is the standard form of 5 plus 6i squared. So if you understand that, you should be okay to perform your very first homework, homework 1 of Module